Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Yeah. So today I'm going to talk about Linux, VirtualBox, and Vagrant. Okay. So this is the tool. These are the three topics which I'm going to talk about. Now, first thing, I hope you know the Windows. There is no problems into that. You all know Windows, how to work it or work with Windows and stuff like that. But for DevOps, okay, for DevSecOps and SRE, and for the sake of any operations work also, you need to learn Linux. I believe some of you are already aware of Linux. Some of you must have a fundamental knowledge on Linux, and also I'll add some additions also. Okay. So, but the question is, how can we get Linux? That is a major question. How can we get a Linux? So, in your laptop, you must have a Windows, correct? So, how can we get a Linux server? So, that is the one question which I'm trying to answer before getting to the Linux, and that you can install Linux in physical box, which we don't have. All of us, we don't have a separate box. So what we do? So we can get a Linux VM in what? In
Hyper-V.
hypervisor and cloud. Okay. Now, when I say hypervisor, that means anyone have idea what I'm talking about?
It's a virtualization software on Windows.
Correct. Virtualization software. It can be on any platform for the sake of it. So which are the hypervisor we are using? So one of the popular one we are using VMware. Everyone must have used at least, because it's not something new. It's there from last 15 years. So I am assuming like we know that, but still I will cover because it's part of session and I cannot expect everyone should know. There is one more popular tool which we have is VirtualBox. There is one more tool which we have is Hyper-V. Okay, so VirtualBox is from the Oracle. There is some noise coming from someone, I guess. Prashana, can you mute yourself? It will be easy for us. Yeah, thank you. So yeah, so Hyper-V, VMware, VirtualBox, Hyper-V. But guys, there's so many other hypervisors are also in the market. Okay, I'm not complicating too much, but there are tens of hypervisors. What these hypervisors are doing? These hypervisors manage VM virtual machines. Simple, manage virtual machine. Now, next question is like, okay, what are the cloud options we have available? So we have AWS, where you can get the VMs, Azure, you can get it. You can get popular one, which is GC, Google Cloud also, you can get the VMs. So here also, you can get the VMs, and here also, cloud also manages your virtual machines. So from last few sessions, I mean, typically I use the AWS, and as part of these sessions, AWS, you have it. And also SRE, we have Azure also, I guess, covered in this. I need to check the agenda also. So this is a virtual machine. So get a Linux VMware. You can get in a cloud also. You can get in a hypervisor. But today's focus is hypervisor with the own laptop, or maybe you have some boxes which you want to utilize for the learning infrastructures and lab and all. You can use that. Though you can go for the cloud also. That is the next session. AWS, we have a, I think today is anyway Sunday, so next Saturday you'll have a AWS session, Docker, Kubernetes, all this thing will be followed by. So yes, today my focus is VirtualBox. Okay, why VirtualBox? So what is VirtualBox? It's a hypervisor. What is a VirtualBox? It's a hypervisor manage VM, virtual machines. Okay, this is the managing the VMs. And when I say managing means what? So you can create a VM. You can create a VM. What you can do? You can start a VM. You can stop a VM. Stop a VM. You can remove a VM. These are the typical things, though you can do much more than that, but I'm not complicating too much. And these are the things. It's a hypervisor which manages your VM for creating VM, starting VM, stopping VM, and removing the VM. Now the question is, what is VM? Anyone have this answer? What is a VM, virtual machines? What is a VM? Anyone? Am I audible, all of you?
Yeah, you're audible.
Yeah. So what is a virtual machines, guys? So forget about the virtual machine. First, let's understand about the physical server. I'll give you the little bit different context. In a physical server, first you have hardware, correct now? Let me draw a picture so it'll be easy for visualization, you'll remember longer. Okay, so in the physical server, you have hardware, and the hardware means CPU, RAM, storage, and blah blah things. On top of that, what you installed? Tell me. On top of that, what do you install?
Software.
Yes, you install software, but can I call it operating system?
Yeah, operating.
Yeah. Now we call it OS, but you know, guys, in DevOps world, you need to deep dive into OS. Why? Because if you don't deep dive into OS, you will not be able to understand the container. You will not be able to understand the many other components which has evolved nowadays. Recently, many technologies has come which directly runs on the hardware. So you need to understand this technology. So now when I define the OS, but so what we have, so in the OS, first thing what you have is a kernel. All of you are agreeing with me?
Mm-hmm.
Yeah. Now what is the question is, what is a kernel? Anyone? What is a kernel? See, I don't know, so I'll put it in Google. And you see here, I put it in Google. What is kernel? Enter. And here, I would like you to just read only few lines. Don't read too much. Here, hardware on top of kernel, and the kernel is this one. So can you please read this? What is a kernel? So kernel is a computer program. It's a program only. It's not a hardware. It's a program. It's some program which has been written. So basically, this kernel which talk to the hardware and talk to the human also, human layers. This kernel is important for all the operating system. All of you agree with me?
Yes.
Yeah. Now, guys, here in the kernel, you have few fundamental things. I would like to state it, but you don't have to remember it. Just be aware of it. Become comfortable slowly, so it will be easy for us. So kernel has a multiple components actually. Remember, kernel is a programs itself, but there are different kinds of program. And one program we call it a namespace. Have you heard about this? All of you? Then we have one program, we have a C groups. Have you heard about this?
No.
There's a one program which is capabilities. Okay. And like that, we have so many different kind of programs in kernel. Now you must be thinking, Rajay, you must be thinking, it's like, why we are discussing this one? Why we are discussing? So you should know actually, without that, latest technology like a container and all, you'll not be able to understand. You should know. So kernel, remember that here you have a hardware and here you have kernel. And kernel, you have namespaces, subgroups, and capabilities. These are the kind of programs we have. You know what? I'll ask you one question and you have to answer. See, there is a one object you create in program. I'm saying oops concept related stuff. There is a one object. Okay, sorry, my bad. There is one class which you created in any program for the sake of Java, C++, .NET, Python, Perl. I don't care. Class is class. So you have a class created. Now you tell me how many objects you can create?
Unlimited.
Unlimited. Do you have any limit? Do you know any limit of that? How many objects you can create? No. As long as there is a CPU, as long as there is a RAM, as long as there's a storage, you can create as many objects. Agree with me? You only answer this question.
Yes.
Okay. So guys, something similar concept here also we have in the kernel. I'm not complicating too much of using the very technical keyword, but you know what? In a namespace, there are different kind of namespace again. One of the namespace is called user. There's another namespace called MNT. There's another namespace called net. There's another namespace called PID. So these are the namespace which you have. So you know what? This namespace only can create a user. Create user. This namespace only create a root file system. Now, what is a root file system? User, you understand easily, correct? All of you?
Yes.
This namespace only create a network. This namespace only called PID map, PID tree. Now, network probably you understood, means getting one IP address or something like that in a simple way. User probably you understood. What is the root file system? Anyone? Anyone? What is the root file system? Hello? Okay, so guys, we have to understand this one also. Okay, so file system is, what is a file system, by the way? What is a file system first? What is a file system? Quickly, all of you. Let's keep this session interactive, so it'll be easy and entertaining for everyone. What is a file system? Collections of
data structure.
files and directory for certain purpose. Correct? Certain purpose. That's a file system. Now, here I should talk about the types of file system. File system. So basically here, there is one, we call it a boot file system. Boot file system. There is one, we call it a root file system. Root file system. There is one, we call it user file system. Okay, and then one we call it app file system. By the way, Git is also file system. I believe some of you might have worked with it. Git repo is also file system. Your application, the one which you copy, is a file system. So these all are types of file system. Now, what is a boot file system? Remember, this is nothing but a kernel actually. So here, this is the kernel. Now, what is a root file system? Anyone? Hello? Guys, let's say you don't know. Just put it in Google. But you must know that. Why you must know? Because it's important you to learn all this latest technology. So, have you? Do you know this all stuff? Have you seen this somewhere? Have you seen this?
Yeah.
So this is a root file system, guys. This is a root file system. That means whatever you see in operating system, it's a root file system. Starting with the C drive, D drive is a root file system. In OPT, in Linux OPT, etc, var, this, that is a root file system. Are you understanding now? Now, what is a user file system? Let me show you rather than talking. See here. This is my user. Look at this. C users Rajesh Kumar. And whatever you see here, guys, is my user file system. Every users will have a download, documents, this, that, and all. And now, what is the last one? What is the app file system? Any apps installed? Let's say today, typically I install all of my app in a C tools directory. Okay. So here, let's say this is a Maven file. So the Maven file system. So now, are you comfortable with the file system concept? All of you?
Yeah.
So guys, here I am saying root file system means this mount, this namespace, kernel has a namespace. This is a different kind of namespace, MNT namespace, which create a root file system. Now you understood that what kind of file system it create through MNT namespace? All of you? Hello?
Yeah.
Yeah.
Yeah. Now, guys, this guy create a PID tree. What is a PID tree? So PID tree, I'm not asking this question. So see here, every process, everything in this whole universe start with nothing, and that's called zero. Okay, that means in a computer also, everything starts from the zero. Yes, and then followed by one, then two. From here two, from here 3, 4. This is a PID number. This is the PID 0, PID 1, PID 2, PID 3, PID 4, PID 100, PID 500. Every process it runs, it create a PID incremented by 1. Are you understanding what I'm trying to say, guys, all of you?
Yeah.
You want to see that PID? In Windows also, I have to log in Linux. Just give me 2 seconds. In Windows also, I can show you that. Where to show you?
Task
Go
manager.
to task manager. I'm just trying to go same place, but this is a Windows 11. That's I'm not comfortable too much. Yeah. So go here, and do you see this here PID? Look at this. See, starting with a 0. Whole universe started with a nothing actually, and then everything has come. So you must be wondering, and you must be asking, where is the 1 and 2? So it's gone after the process. 4 is still running, so it's there. And you see that incremented on stuff that you must be thinking, where is this remaining 18,000? Because I see only 200, 300 services for a PID. So remaining is gone. You killed it somehow. You just see, you open a browser and close it. It's on PID. Are you understanding what I'm trying to say? Hello?
Yeah.
So guys, here, this is a whole structure is called PID tree. Means whole structure starting with the 0 to whatever the process is required, it's create a PID tree. Now in this guy, PID namespace created PID tree. Okay, now probably I'll give you a little bit of visualization so you'll remember this discussion. So let me just a second, hold on. So Linux kernel container. Just a second. Everything you have in the Google only, just you have to have a right start for it. Okay, nothing I'm going to teach you, I'm just going to show you the way. So see here, this is a good image. Look at this. See here, only this, look at this Linux kernel. C groups, namespaces, C Linux, capability, app armor, net filter, netlink. I was talking about the namespace, which is important for me in this session. Understood, all of you?
Raj, one question. So namespace is like it hides some set of resources, right? I mean, some set of process users to other set of users to avoid some kind
Namespace,
of collision, right? So in that
namespace is,
aspect, yeah.
see, kernel is what? Program. So namespace is also program, but types of program. Using this program, what you can do? You can create a user, you can create a root file system, you can create network, you can create a PID tree. That is what I'm trying to do. It's a computer program. Remember, you just read this line. That's all. Don't get confused. Got it?
So namespace is a program which which groups all these, right? I mean, users, mount, and net and PIDs into one unit. Is it?
Yeah, something like that. Yes, you can say. For example, you know that when we design a software, we convert into a multiple module and stuff like that. Correct, no?
Packages,
So
modules,
you
or
can
something like that.
correct. So you can say this is a module 1 for kernel, module 2 for kernel, module 3 for kernel, and each module has certain functionality. That one I'm explaining it to you in a simple way, not getting into too much of that, to be honest. Okay, make sense? Okay, can I move on? Okay, now guys, tell me, ask can and allowed. Okay, tell me one thing, guys. Opposite way. I will ask you questions. You have to tell me. Okay, I will ask you a question. In any operating system, how many users you can create? Tell me. How many users you can create in one operating system?
There is a limit actually. There is a limit we can set for number of users, number of PIDs.
Oh yeah,
Default
number of
1024,
users.
right? Default is 1024.
102. I mean,
1024. 1024.
Number of users.
Some U limit or something is there, right?
No, I'm not saying use limit. Users, number of accounts, users in operating system. So, see, it's just approximately around. See the numbers. I mean, still have to read this more. Correct. Look at this billion. Are you seeing this?
Do you mean
So
users
basically,
in the same
no.
operating
What I'm
system
trying
or-
to say, how many users you can create in an operating system? Unlimited. Simple. So how many users you can create? Unlimited. How many is allowed? Unlimited. How many it can create? Unlimited. Why? Why it can unlimited create? Guys, have you forgotten this concept? Tell me. You only answer. Someone has answered this question.
Mhm.
Class, you can create objects unlimited, don't you? So user is also programs. You can create as many. You can instance create as many you want it. Make sense?
Mhm.
How many mount root file system you can create? Tell me.
One.
Root, wonderful. But how many theoretically you can create? Unlimited. Theoretically, mind it. You have seen, I know that you have seen, I have seen also only one root file system in one operating system. But you know that you can create unlimited. Yes, kernel allows you to create unlimited root file system in one operating system, but operating system don't allow. There's a difference between kernel and operating system. How many networks allowed? Unlimited. Allowed one, and create unlimited. Same concept. And pit tree allowed only one pit tree, but you can create unlimited. So are you comfortable with this concept? What I'm trying to say? All of you?
Yes.
Guys, manage C groups. Someone asked me, hey, what is the C groups doing? So managing CPU plus RAM for the PID. Simple. I'm not complicating. And capabilities, what they are doing. So giving access, root, non-root access, root access to users. This is the, by the way, there are more components I don't need right now. So here, let's figure it out. What I was trying to do, let's try to figure it out. Here we have a hardware. Look at my screen, guys. This is the hardware. Okay, and on top of that you have a kernel, and this is the kernel, mind it. And the kernel, as per the discussion, these are the namespace. So user namespace, mount namespace, network namespace, and the PID namespace. But here they can create only one root file system. So they create a root file system, which you see C drive, E drive, OPT is a root file system, RFS, and one create one network, one create one PID tree. Here you said one PID tree and a network. And you know, guys, let me here, and you can create as many users you want. One user, two user, three user, four user, five user. All the users share the same PID, same network, same root file system. That means all these users would able to use the same C drive, D drive in a simple way, if I say, or same network on same PID tree process ID. Are you able to understand now the structure? All of you?
Yep.
Hello? Yes. So guys, now the question was, I am not complicate too much again, get into that, but understand that these are the types of file systems which we have in operating system. These are the kernels you have, namespace you have, C groups you have, capabilities you have, and everything you have. Now the question was, what is a VM? So can I answer this question now?
Mhm.
Yeah. So guys, look at my screen, and it's very important. MS Paint. This is the new architecture altogether, and that is, see here, this is the hardware, and the hardware on top of that, what you have, kernel, and top of that kernel you have a hypervisor like a VMware. Okay, hypervisor like a VMware. And what this VMware is doing, you know what? They'll take one image. Have you heard about this? Like whenever you install in your operating system, you take an image like ISO file or something like that. Correct? Now, today I'll show you the demo anyways, but I don't know how some of you might have done it this one. Correct? Now? Yeah. So this
Yeah.
image is nothing but a file. So image is what? Image is containing what? Remember, this is a please hard code. Hard code this statement. Image OS image contains what? Contains this file system. It contains boot also, it contains root also, it contains user also, it contains app also. Simple. So what they do, the hypervisor take that image and they create a one instance like this, one more instance, and whereas they whatever that it has a file system, they run it. So here you have a kernel, and then on top of that root, on top of that user file system, and also an application file system. So whatever you have in the image, you run it here. So this whole things, each VM, this is the virtual machines, this is one virtual machine, this is one virtual machines. So see here guys, understand that in the base machines also you had a kernel, which is a nothing but operating system, and each VM also you get a kernel. Agree with me? Are you understanding?
Yeah.
And when you get a kernel, then you get this one also. See here, when you get a kernel, I explained it to you now, namespace concept. These are the namespace, and you get everything. So basically, in a simple way, see this CPU is from the hardware. See, this CPU is coming from this here only. This CPU is coming from here only. RAM is coming from here only. Storage is coming from here only. But the file systems, kernels, root file system, and user file systems are different. So they behavior as if it's independent, but it's not. The behavior of the VM is independent. So once you log in as an end user, once you log into this VM, you'll say, hey, I got operating system, but it's not operating system. It is a virtual machines with a root file system, with the kernel file system, root file system, user file system, application file system, powered by the base machine of the CPU and RAM and storage. Are you understanding now?
So the kernel between VM and main system kernel program, are these both are communicate like communicated with
No. For this only for this kernel, I'll select here this different color. I would say here for this kernel, this is just a process. This is just a process. Yes, process. Remember, for this anything it can. So this virtual machine is a process for the host machine. This virtual machine is also process for the host machine. This virtual machine is a process for whole machine. But in this kernel also a one bit tree created now. I'll put it in a one way here. See here. This is the base machine. This is the base machine, and here you created 0, 1, 2, 3, 4, all these things, and now you create a VM. You know what? Just I'm not able to. This is the 3 process. So let's say this VM for the host machine. This is the 3 process, but for this inside the VM, it will start from the 0 because I said bit tree definition. So it will start from 0 again, 1, 2, 3. This is the whole relationship that's created. So every VMs you'll see starting with a 0 itself. But if you go to the host machine, this VM PID ID will be maybe 3, 4, 5, or 10 or whatever it is. Are you understanding? So basically what is happening, this guy is asking the CPU and RAM for this guy, and this guy is asking from the host machine C groups. And that is how the whole relationship is working. At a high level, did you understand?
when I hit the PS tree on VM, it will not show a PID of actual kernel system. It will show only
it will not.
VM
It
level.
will show you the only host.
PS tree.
Yes, that's
not level only, not at physical hardware kernel, that program level.
Yeah. So guys, in short, virtual machine is nothing but a running copy of boot, root, user, and app. Running copy of this one. So OS image is like a static copy. This is not running. The moment you run, it's become a virtual machine. And that is managed by who's managing? Hypervisor, like a VMware VirtualBox and all. Are you understanding at a high level?
Image is like
Hello?
ISO file, right? Image is
Yes.
something like ISO file that we use.
Yeah, ISO file contains what? All these file systems.
Okay.
Okay, so guys, let me move on to the next topic. Before that, you know what? I will start one download, and that is.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 3D99 plan, and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.